Hi all. In this session, we are going to discuss about the rules of domain. So our chapter is function. In functions, we can obtain domain and range. Right. So in this session, we are going to discuss rules of domain. Right. Okay. Suppose we have functions f of x, y is equal to f of x be our function, right? Or we have function that may be square root of f of x, right? Or the function may be in the form 1 divided by square root of f of x, or suppose sine inverse f of x, or suppose some cos inverse the function f of x, right? Now, suppose we have function 1 by f of x, right? In these all cases, we have certain rules so as to determine the domain. So in this section, we are going to discuss the rules of domain. Or suppose we have two functions, suppose f of x plus g of x, right? Or f of x multiplied by g of x, or this may be plus or minus, right? Or we have f of x divided by g of x, right? Or suppose we have odd root, cubic root of f of x, or fifth root of f of x, or that may be some even root of f of x, suppose some 32th root of f of x, or f of x raised to some 1 by 6. That is, this implies sixth root of the function. Sixth root of function. That is even root. Right. Now we have some rules for determining domain. In all these cases, we are going to discuss about it. Right. So we have function, right, f of x. We want to determine the domain and range of this function. Right. So functions may be in different form. So there is some common rule so as to determine the domain of the function. Right. Okay. Now we know the domain. What is domain? Suppose I am writing the function y is equal to f of x. Right. For example, a function y is equal to some 10 times sine, oh my god, suppose sine x, 10 sine x, right? Okay. So here we know that this variable x is independent variable, right? Independent variable or input variable, or it is also called domain. And y is our dependent variable, right? So the value of function y will depending on the value of x. So we can say y as dependent variable, right? Okay, so we have y is equal to 10 sin x. Now I am going to draw this figure, right? So we have y, then x, right? This is a sinusoidal function. So we can draw a sine wave, right? Okay, and the value of x is 0. This is positive value and negative value. So what is the value of maximum value is 10. So we can mark it as 10, and the minimum value can be marked as minus 10. So this is the graph for this function y is equal to 10 sine x. Right. Now, our objective so as to develop certain rules so as to find the value of domain and range. So I'm briefly explaining domain. What is domain? Domain is the value of x for which the function is defined. For which function f of x is defined. domain is also called as set of pre-images. That is set of pre-images, right? Or we can say, look at this figure. This will represent x-axis. So this will go to minus infinity, and this will goes to plus infinity. The value of x varies from minus infinity to plus infinity. So look at this width. That is the range of value of x, or width of x, right? So we can say a domain is the expansion of the function along x-axis. That is, this is the x-axis, and the function is expand from 0 to infinity. So the value of x varies from here 0 to infinity, and also from 0 to minus infinity. So we can say domain means the width or the expansion of the value along the x-axis. So we can also say domain means expansion of graph along x-axis, right? X-axis. That is a domain. Or we can say domain is the width. Width means along x-axis. That is why I am using the term width. Means this is along x-axis. That is the domain. So all these are domain. That is the value of x for which the function is defined. The set of pre-image, and domain is also called the expansion of graph along x-axis, or this is the width of the graph along x-axis. These all are our domain. Then what about range? Range means this height, right? That is the value of function along y-axis. This is our y-axis. So minimum value is 10, and maximum value is plus 10, and minimum value is minus 10, right? So we can say range of a function. What is the range of a function? Range means the value of y for valid x. So we can say for valid x, right? The corresponding value of y is called range. So valid x, the value of y is called as range, and it is also called image or set of images, right? Set of images. This is also our range. Or we can say this is height of graph along y-axis. Height of graph along y-axis, right? Okay, this all right. So we can say that, or the expansion of graph along y-axis. Here the expansion is from minus 10 to 10, right? So we can say range means expansion of graph along y-axis. So expansion of along y. Okay. So these are all our definitions of domain and range. So we can say, suppose we have function y is equal to f of x. Then domain means the value of x, right? And it is also called set of pre-images, expansion of graph along x-axis, and this is also called width of the graph along x-axis. Range means the value of y for valid x, right? If the function is defined for certain x, then the corresponding value of y is called range. This is also called set of images, right? This is also called height of graph along y-axis, right? Or expansion along y-axis. This is a basics or for different names for domain and range, right? So suppose we are using pre-image. Pre-image means domain. Image means range. So domain means the graph along x-axis. That is expansion along x-axis. And range means the expansion of graph along y-axis. So we can simply say domain means width, right? Width, and range means height. Okay. Okay. This is the manner in which we can determine, right? So for y is equal to 10 sin x, we have domain. Domain of this function is R, right? That is set of real numbers. So this is equivalent to open interval minus infinity to plus infinity. Right. So this is the domain of this function. Now, what's the range? Range of this function, r suffix f. Okay, this is equal to the minimum value of 10 sin x is minus 10 and maximum value is 10. So range of the function belongs to minus 10 to 10. Right. Okay. Now I'm drawing another figure. Now we want to determine the domain of that function, right? Domain and range of the function. Suppose you assume a graph. Suppose this is our function y is equal to f of x, the function of x. Suppose this is our graph, right? Now I am giving an open bracket here, open circle. Open circle means this point 0 is not included. Here also I am using an open circle. That means this point is excluded, right? So this is our graph. Suppose I am giving the value of this point is of 2010 and value of this point, suppose some 1010, this is graph by x, right? So we want to determine domain and range of this function, right? So this is our graph. This is a continuous figure, right? Continuous graph. But this point 0 and at this point 2010, we have an open circle. That means that point is excluded. So the domain of this function is this width, right? This width, that is width expansion along x-axis. That is called domain. So we can starting from 0 to 2010. But at 0, we have an open circle. At 2010, this value also a open circle. That means that value is excluded. So domain of this function is starting from 0, open bracket. That means 0 is not included, up to 2010. This also is not included. And range of this function, range means width along y-axis. So this width is called the range of the function, right? This height, this height is called range of the function. What is this height? Starting from 0 to 1010. But here is an open circle. So this point and this point is excluded. So the range is 0 to 1010. Both the n values are excluded. So this is the domain and range for this figure. Now I'm drawing another figure. For example, we require to find the domain and range, right? For example, suppose this is my axis. I mark x-axis, y-axis, right? Okay. That this is 10. And then this point I'm marking as 5. This is 0 or origin, right? Suppose this point is some 20. This point marking as some 40. Arbitrarily marking, right? Now, I am drawing a curve like this. This is not touching 5, right? That is not touching 5. And here I am using a dark circle. That means that point is included, right? Now I am drawing a curve like this. Okay, this is also not touching the point 5. So this from this figure, we can see this is not touching the point 5. So 5 is excluded, but domain is 0 to 40. So this width, that means expansion of this graph along x-axis, that is called domain. So we can see 0 to 40. So for this figure, domain is from 0 to 40, right? Since both this 0 and 40 is included. So we have a closed bracket here. Now, what about range? Range means we know that the height of the graph or expansion along y-axis, right? This height. So we are starting from 0 to 10. Here is a dark circle. So 10 is included. But look at this point 5. This graph is not touching this point 5. Also, this graph is also not touching. This is a point 5. So from 0 to 10, the graph is not touching the point 5. So 5 is excluded, right? So we can say the range of the function is from 0 to 10. Here 0 is included. Similarly, 10 is also included. But it is not touching the point 5. So we can exclude the 5. So closed interval 0 to 10 minus set 5. This is a range of this function, right? So in short, we can say the value of x for which the function is defined is called domain. That is also called the expansion of the graph along x-axis, right? And range means the value of y, right? For valid x. Suppose the function x is the domain, then the corresponding value of y is called range of the function, right? This is also called expansion along y-axis, also called image of the function, right? Or height of the function, that is a range. Okay, this is the basics of domain and range. Now we can develop certain rules so as to obtain the domain and range. Suppose I'm writing first row. Suppose I have a function f of x, right? So we can write rules of domain. Okay, rules of domain. The first rule, our function may be in the form square root of f of x. Okay, or this may be 1 by f of x, right? Or the function may be in the form 1 divided by square root of f of x, right? So this is our first rule. So we have function y is equal to f of x. So function is given, f of x is given inside the square root. Here 1 by f of x, that is function is given in the denominator, and here 1 by square root of f of x. So how will we determine the value of x in these three cases, right? Now, first look at square root of f of x, right? And we know that square root is a positive quantity, right? Square root is a positive quantity. So this quantity will exist only if f of x is a positive function. That means this will exist only when f of x is a positive function. That is, f of x is a positive function, right? We know that is square root is defined only for a positive function, since square root is a positive quantity. So whatever inside the square root should be positive, then only this function is defined, right? So we can assume f of x a positive quantity means that this may be 0, right? So we can say this is a non-negative quantity. F of x is a non-negative quantity. Non-negative quantity means that is a positive, either positive quantity or 0. So this is defined only if f of x is greater than or equal to 0, right? F of x may be 0. The square root of 0 is equal to 0, or a positive quantity. F of x should not less than 0. That should not be a negative quantity, right? Then square root is not defined, right? So in a problems in this type, square root of some function, then we can obtain the domain by using this inequality, that is f of x greater than or equal to 0. Okay, now here f of x coming in the denominator. So denominator quantity never equal to 0. Suppose if f of x is equal to 0 means this is equal to 0 means then 1 by 0, that become infinity, that is not defined. So this function exists only if f of x is a positive quantity, that is f of x greater than 0. This is not equal to 0, right? Now look at this. Here f of x is under square root and also coming in the denominator. So this will exist only if f of x not equal to 0 and f of x greater than 0. That means we know already told whatever inside the square root, that should be a positive quantity. This means f of x that is greater than 0 but not equal to 0. So if the functions are coming like this, we can obtain the value of x by using these conditions. We can do some simple problem based on this. Okay, suppose I have a function square root of 3x minus 4. Okay, this is 1 by 3x minus 4. And this function is 1 by square root of 3x minus 4. Okay, determine the domain. So we know that the quantity inside the square root should be positive. That happens when f of x greater than or equal to 0. So we can write this is equal to 3x minus 4 greater than or equal to 0. Then only this function is existing. So solve this inequality. We will get x greater than or equal to 4 by 3. So for all the values x greater than 4 by 3, this function is defined. So we can say the domain of the function means the value of x, right? X belongs to, that is closed interval 4 by 3 to open interval infinity, right? So this is a domain. So we can draw this domain as in number line. I am drawing the number line here, marking 4 by 3, right? 4 by 3. This 4 by 3 is included, and this is greater than 4 by 3. So this region of the number line will represent the domain, right? Okay, now look at this condition. The denominator function is 3x minus 4. So 3x minus 4, no, here it is not square root, right? So the domain of this function, there is a correction, right? Here there is no square root. So here f of x is not equal to 0, right? F of x not equal to 0. And f of x is equal to 0 means denominator 1 by 0 infinity. So the domain of this function is determined by using f of x not equal to 0. That may be either negative or positive, right? This is a way to determine the domain of 1 by f of x. So it's a correction, right? So we have function 3x minus 4, 1 by 3x minus 4. So we can say 3x minus 4 not equal to 0 or x not equal to 4 by 3. So this is our domain. So domain means the set of real numbers, that is x belongs to minus infinity to infinity, excluding the number 4 by 3. This is the domain. Or we can also say x belongs to R. R means open interval minus infinity to infinity. That is replaced by set of real numbers. R minus 4 by 3. This is the domain. Now, here, the third case, we have 1 by square root of 3x minus 4. So, this quantity 3x minus 4 not equal to 0, and the quantity inside the square root should be positive. So we can write 3x minus 4 greater than 0 or x greater than 4 by 3. So the domain means x belongs to open interval 4 by 3 to infinity, right? So this is the domain. Okay. Okay. Now, suppose we have, this is the first rule for determining the value of x, right? Now, suppose we have combination of functions. Suppose we have two functions, defined function, f of x and g of x. We need to find the value of domain, right? So, we can say I have two functions, f of x and g of x. We want to determine the domain. Suppose this is our second case, right? Either the function may be f of x plus g of x or f of x minus g of x or f of x multiplied by g of x, right? Or f of x divided by g of x, right? So we have four cases, case 1, case 2, case 3, and case 4, right? We want to determine the domain. Okay, so let the domain of f of x is denoted by d of x. So this is our domain of function f of x, right? And dg, this will indicate the domain of function g of x, right? Now, suppose we have this combination, then here this g of x, the fourth case, g of x not equal to 0. Suppose the value of g of x is 0, the denominator become f of x by 0. That is become not defined. In the fourth case, the value of g of x is not equal to 0. Here, the domain of this set, that is the intersection of d of f d of t. This will give the domain, right? So, in second rule, if the function is in this combination, either plus or minus, that is, in general, we can say f of x, either plus, minus, multiplication, or division of g of x. Then common domain, right, is equal to the intersection of the domain of f of x with the domain of g of x. Right. In this manner, we can determine the domain. Okay, based on this, we can do certain problems, right? Okay. So when we are doing division, that is f of x by g of x, the things that we have to remember is the quantity in the denominator should not be negative. That means g of x is not equal to 0. Right. That should be keep in mind. Okay. So based on this, we can do something. So I have a question. Okay. And this also. So consider a question. Square root of x minus 6 plus square root of 4 minus x. Determine the domain or the value of x. So we have sum of two functions. We can consider this function as f of x plus function g of x. Right. Now we know that the x minus 6 coming inside the square root. So anything inside the square root should be a positive quantity. Right. So we can say x minus 6, that may be greater than or equal to 0. X is greater than or equal to 6 for f of x. So we can draw number lines. X may be 6, right? If x is 6, the value inside becomes 0. Square root of 0 is defined. So this is a number line, right? 0. So this is 6. 6 is included. So a dark circle. So all the values greater than 6 is the domain of this section, right? So we can mark this region in the number line, right, for this f of x. In the case of g of x, we can say 4 minus x, that is greater than or equal to 0, or minus x, that is greater than or equal to minus 4, or x less than or equal to 4. Right, when changing the sign of inequality, multiplied by minus both sides. So here x should be less than or equal to 4. So in the number line, we can mark 0. This is 4, right? 4. So all the values less than 4. So this region of the number line, is x less than or equal to 4. All this region, right? So this function, we have x greater than 6. I'm marking this 4 here. So for this section, what is x is less than or equal to 4, this region. So the domain of this function is the intersection of both this one, that is should be greater than 6 or x should be less than or equal to 4. So there is no common region. So there is no x satisfying both this condition, right? This should be greater than 6 and this should be less than 4. So domain is null set, belongs to 5, null set. That is, there is no value of x is satisfying these two conditions. So we get domain of this function is a null set, right? Okay. Okay. Now we can consider the same problem by changing the values, right? I'm making a small modification for the same question, right? Now let our question be square root of x minus 4 plus square root of 6 minus x, right? Find the domain. So first find the domain of this section and this section and find their intersection, right? So we can say the domain of this function, that is inside the square root, that should be a positive quantity. X minus 4 greater than or equal to 0, x greater than or equal to 4, right? So in number line, we can mark a point 0. So all this value, all the values greater than 4. So this region of the number line will represent the domain. Okay, I'm marking this like this. and 4 is also included, so a dark circle. So all this entire region greater than 4 in the number line is the domain of this section. Now consider this section. We can say 6 minus x greater than or equal to 0 or minus x greater than or equal to minus x. Now multiply both sides LHS and RHS by negative. So that will change the sign of inequality. So this is equal to x less than or equal to 6. Right. So in the number line, we can mark this section as this is our number line, right? This point is 6, right? This point. Okay. So all the values less than 6, or we can write 0, 6. This region of the number line, right? And there this region. I'm marking this. Okay, this flow is showing this region. Okay, so I am drawing both this figure in a single number line. So 0. For this case, this is greater than 4. So hold this region. For this section, that is less than 6. So like this is 6. So the region less than 6 means the entire region that goes here. Okay, so intersection of these two will give the common domain. So find the intersection of these two. So we have, this is our intersection, right? Intersection of both this area, right? So this area will represent the domain. Both 4 and 6 are included. This is 4 is included, 6 is also included. This is a common to both this section, right? So we can say x belongs to closed interval 4 to 6, since both 4 and 6 are included, right? In previous case, we get a null set. So in this manner, we can determine the value of domain, right? So if functions are either addition, subtraction, division, or multiplication, what we have to do is we find the intersection of domain of the individual function, right? Okay. Now we can do another problem. Now suppose we have a function f of x that is equal to square root of x minus 4 divided by square root of 6 minus x. Right. This is the form f of x divided by g of x form. Right. So here the quantity or function with the denominator should not equal to 0. That is g of x not equal to 0. Right. G of x not equal to 0. Okay. Now, first I am considering the numerator function square root of x minus 4, and we can consider square root of 6 minus x. Right. So we know the domain of this function x minus 4 greater than or equal to 0. So x greater than or equal to 4. Here 6 minus x greater than 0. That is not equal to 0, right? Since g of x is lying in the denominator. Or we can say x is less than 6. 6 is not included, right? So in the number line, you can draw, this is starting from 4. For this section, 4 is included. So a dark brown circle. So, and this entire section, right? And for this section, the starting from 6, but 6 is excluded, right? So I am using an open circle here, and this entire region in the number line, right? This entire region in the number line corresponding as less than. Now find the common region. Common region, we know the intersection is this region, but here 6 is an open circle. So we can say, and using a dark circle here, okay, an open circle here. So x belongs to closed interval 4, so closed bracket, and 6 is excluded, right? So open bracket. So this is the domain of this function, right? Okay. Now we can do another problem. That is the domain of a polynomial function. What is the domain of a polynomial function? Domain of a polynomial function is always R, that belongs to R, right? So we can write a polynomial function f of x that is equal to a0 into x raised to n plus a1 x raised to n minus 1 plus a2 x raised to n minus 2. This goes on and the last term become a n, a n x, right? So by going this, and last term is a constant term a n. Before a n minus 1 x, right? Before this, there may be a n minus 2 x square. So this is a polynomial function. For any polynomial function, whether a quadratic function, linear function, cubic function, or biquadratic function, for all polynomial function, domain is always set of real numbers. For this function, domain belongs to R, right? That is set of real numbers. That means x belongs to R. So we can say x belongs to R means open interval minus infinity to infinity. So any polynomial function, the domain is set of real numbers. So based on this, I'm going to do a problem. That is problem consisting of a polynomial function. Okay, let us do. So I have a function y is equal to x cube minus x square plus x plus 1. This multiplied by square root of x square minus 4. Right. So this is a product of two functions. We can consider this function as f of x. Right. This function can be considered as g of x. And we know that this is a polynomial function, a poly function, right? Polynomial function, right? And for the polynomial function, domain means x belongs to R, or we can say x belongs to R, or x belongs to open interval minus infinity to plus infinity. So this is the domain of this polynomial function. Now we have a square root function, right? Square root of x square minus 4. And we know that whatever inside the square root should be positive quantity. So we can say x square minus 4 greater than or equal to 0. Now fractionalize this. We can write this is equal to x minus 2 multiplied by x plus 2, that is greater than or equal to 0. Or solve this inequality. We can say x is greater than or equal to minus 2 and x less than 2 or equal to 2. This is the solution. We can, by using curvy wave method, we can solve this inequality by marking these points on the number line. I am marking minus 2 here. This x is minus 2 and x is equal to 2, right? Now, starting from here, this is plus, minus, plus. So this region is positive and this region is also positive. So this is positive for x less than or equal to minus 2, union x greater than or equal to 2. Okay, union. Here it is OR operation, right? Or means either this condition. So inside minus 2 and 2, the value of function is negative. So we can say x, right, belongs to minus infinity to, this is going to minus infinity, and this number line is going to plus infinity. Minus infinity, minus 2 is included, union, or union means or 2 to infinity. Right. This is a domain of this section, and domain of this section is R. So by combining, by taking the intersection of these two sections, we will get x belongs to minus infinity to minus 2 union 2 to infinity. This is the domain, right? Or we can say x belongs to the entire real number, excluding the values in between minus 2 and 2. Minus 2 and 2 is included, so open bracket minus 2. So both this will represent the same. So set of all real numbers excluding this quantity. This quantity means the numbers in between minus 2 and 2, right? Okay, but 2 is included. In this manner also we can represent. This manner also we can write. Both this will represent the Same thing. Right. Now we can do another problem related to finding the domain of a function. Okay, now consider the question. The problem y is equal to square root of x minus 3 plus square root of 5 minus 8. A simple problem similar to the previous case. So we can write the domain of this section is x minus 3 greater than or equal to 0 or x greater than or equal to 3. Here we can write 5 minus x greater than or equal to 0 or x less than or equal to 5. So in the number line, we can represent this portion as we have 3. 3 is included. So all this section that's greater than 3. For this section, we can write 5. 5 is included. Here it is 5. Okay, 5. All this section. That is all that is less than 5. So by combining these two or intersection of these two, we will get the domain is this portion. This portion is in between 3 and 5. Both 3 and 5 are included. So we can write x belongs to closed interval 3 to 5. Right, a simple problem. Right. Now we can do another problem of same type. So as to find the domain and intersection. Right. Okay. Now I'm writing another question. Y is equal to x minus 3 in the numerator divided by x plus 3 multiplied by x square minus 4, right? So it's a combination of 3 functions, x minus 3 in the numerator, x plus 3, and this term in the denominator. So the common domain is the intersection of all these 3 individual functions. Now I am writing x minus 3, first term of function. Here we can write x plus 3. Right. Here we can write square root of x square minus 4. Right. This is a first order polynomial. First order polynomial function. So x belongs to R. Right. This is also a first order linear function x plus 3. But this x plus 3 is coming in the denominator. Anything in the denominator should not be equal to 0. So for this function, we can say x belongs to R. Since for a polynomial, the domain is set of real numbers. But this factor is coming in the denominator. So x should not equal to minus 3. When this becomes minus 3, what happens in the denominator? Minus 3 plus 3, that becomes 0. So this divided by 0, that is infinity. So by we are excluding minus 3, right? So x belongs to, we can say, minus infinity to infinity, excluding minus 3. So minus set of minus 3. So this is the domain of this section, right? Now for this section, x square minus 4 is coming inside the square root. So anything inside the square root should be a positive quantity. And this is also coming in the denominator. So it is should not equal to 0. So x square minus 4 greater than 0. This not equal to 0. Since when this becomes 0, the 0 will come in the denominator. That will make the function infinity. So we are using the inequality x square minus 4 greater than 0. So we can solve this as x minus 2 multiplied by x plus 2, that is greater than 0. Or x is greater than minus 2 union x is less than 2. Right. Or we can say, in this case, x belongs to minus infinity to minus 2, here, open bracket, union 2 to infinity. Right. Okay. Now we can draw these all 3 cases in the number line. and find the common domain. So I am drawing the number line. Okay. Here x belongs to R. The entire x or entire real numbers. For here, we can write -3 is excluded. So an open bracket, open circle, -3, right? For this section, x is from -infinity to -2. So we can write this is -2, right? So x belongs to -infinity to -2. -2 is excluded. So an open bracket, right? -infinity and 2 to infinity. 2 will come here. 2 is also excluded. So I'm marking 2 here. 2 is excluded and that is greater than 2, right? This is the area. Okay. Now, what is the common area of these three? We have -3 will come here, right? So x is -infinity -2 and union 2 to infinity exclude -3. -3 is not included. So we can say the common domain x belongs to -infinity to -2 union 2 to infinity. Since 3 is greater than 2, so 3 is coming here, but 3 is not included. So minus 3, right? This is the domain. Or we can say this is equal to another way, x belongs to -infinity to +infinity, set of all real numbers minus the numbers coming in between -2 and 2. -2 is not included. So, and close the bracket. Okay, -2 to 2. -3. 3 is also not. So, set 3, set of -3. Right. So, this is another way of representing the setting. So, the set of entire real number excluding the numbers lying between -2 and 2, both including -2 and 2 is not included in the domain. Also, -3 is also not included in the domain. So, x belongs to set of real numbers excluding all the numbers in between -2 and 2 and also -3, right? -3 will come here, right? -3 will come here, not here. This is +3. Okay. -3 here. This point is excluded, right? Now, we can do another problem related to same, right? Suppose we have function. I will write just a minute. Okay. Now, consider a function y is equal to square root of 2 minus x minus 1 by square root of 9 minus x square. Okay, find the domain of this function. So we have two sections. For this domain, we can write 2 minus x greater than or equal to 0. Right, here 9 minus x square, that is greater than 0. 0 is excluded, right? Since this term is coming in the denominator, right? When this becomes 0, the denominator becomes 0. So 1 by 0, that will be infinity. When x is equal to, when this quantity becomes 0, right? So we can write this is equal to minus x greater than or equal to -2, or x less than or equal to 2, right? By solving this inequality, we can write this is equal to x square minus 9 less than 0, or factorize x minus 3 multiplied by x plus 3, that is less than 0. So x belongs to open interval -3 to 3, right? So in number line, we can draw this as, here is x is less than or equal to 2. I am marking 2 here. 2 is included. So a dark circle. Okay, this area. This is less than 2. For this section, we can write x lies between -3 and 3. Let this be 0. So we can mark this is minus 3 and 2, 3, right? So x is like 3, that is both 3, minus 3 and 3 are not included. So we can say this area, right? Both minus 3 and 3 are excluded. Now, what is a common area or intersection? Intersection become, we have this section, right? And up to this 2 is included, but minus 3 is excluded. So this area will represent the intersection. Okay, so we can say x belongs to open interval minus 3 to 2. 2 is closed interval. Right, so this is a domain for this function. In this method, we can find the domain of any combination of two functions. We will discuss the remaining topics in detail in the coming session. Okay, thank you. Bye. Keep watching.